Good day, everyone. Today we shall see about the next topic, which is sign convention of lenses. So, just like spherical mirrors, the same sign convention is applicable for the lenses also. So, we shall just brush up the 5 basic rules of sign convention. The first one is the object is placed on the left of the lens and the eyesight should be on the right side. So that is the first sign convention. So the object is placed, as you can see in the picture, on the right side of the lens, and we are viewing the lens and the object from the right hand side. The second one is all the distances parallel to the principal axis are measured from the optic center O. So that is, in the lenses we would have seen the same sentence. Instead of optic center, there we will encounter with pole P. Instead of a pole, since it is a lens, here we have got the optic center. Other than that, it is the same explanation. All the distances parallel to the principal axis we are supposed to measure from the optic center O. Now all the distances to the right of the optic center, that is from O, whatever you are measuring towards your right will get a positive sign, and whatever you are measuring towards the left hand side, whether it be the object distance, image distance, whatever you are measuring from the optic center towards the left will get a negative sign. So that is the third rule. Then the fourth sign convention is all the distance perpendicular to and above the principal axis, that is, if you are measuring above the principal axis, it is termed as positive, that is towards your y-axis. If you are measuring it above the principal axis, it is positive, and below the principal axis, it is negative. So these are the 5 sign conventions. So as you see the picture, it is the convex lens which is used, and the red color thing is the object, and the eyesight is at the right hand side. So whatever we are measuring from the optic center towards the left hand side, whether it be the object distance or the image distance, here in the picture the object distance is given as minus u, and the dotted line of image, that is termed as minus v. The minus signs are denoted because it is measured from the optic center towards the left hand side. Similarly, from the optic center towards the right hand side, whatever we are measuring will be taken as a positive sign. So these are the 5 sign conventions. So there is no separate sign convention for a convex lens and a concave lens. Both has got the same sign conventions. So there is no separate sign conventions. All the 5 rules are applicable for both convex and concave lenses together. And if it is a convex lens, then the focal length is considered as positive, and if it is a concave lens, then the focal length is considered as negative. It is a very important point while solving the problems. So plus f, it is a denotes it as a convex lens, and minus f will denote the focal length of the lens as a concave lens. So next one is your lens formula. Lens formula, it is similar to the mirror formula. Instead of a plus there, you encounter a minus here. So 1 by f is equal to 1 by v minus 1 by u. You already know that f is the focal length of the lens, and v is the image distance, and u is the object distance. So 1 by f is equal to 1 by v minus 1 by u. That is the only difference between the lens formula and the mirror formula. The next one is the magnification of the lens. Magnification is nothing but how many times the object and the image are enlarged or diminished in size in a comparison. Okay, so it is a ratio. It is a ratio of height of the image and the height of the object. When you encounter the word ratio, that means it is divided. So it is height of the image divided by height of the object. This magnification of the lens, it is actually it is expressed in 2 ways. One is with the height of the image, and the other is with the image and the object distance also. So first expression is m is equal to height of the image, that is denoted as hi, divided by height of the object, denoted as ho. The second expression is m is equal to image distance, that is v, divided by the object distance, that is the u, v by u. So there is no unit for magnification, as both are of the same quantities, both cancel out each other. So there is no unit for magnification. But while writing the answer, if asked in any question, you have to write it as 2 times enlarged, 5 times diminished. You have to mention the how many times the object, height of the object and the height of the images as a ratio. So as a summary, we can see the magnification m is equal to hi by ho is equal to v by u. And one very important point according to magnification is, if m is negative, that denotes that the image is real and inverted. That means we are getting the image below the, that is below the principal axis. Okay, the green color line which you are seeing in the first image, first picture, that is the image distance, and it is real and inverted. Since it is below, we are denoting it as negative. Similar manner, the dotted green color line in the second image is a positive image. Okay, so that is, since it is appearing above the principal axis, perpendicular and above the principal axis, we always measure it as positive. So magnification, if it is denoted as negative, that means that the image is real and inverted. Magnification, if it is termed as positive, then it means that the image is virtual and erect. Okay, this is the first example which is given in our book after the sign convention of lenses topic. So with all the formulas, I am not going to work out the problem, but I will give you the hint of how to work it out. So given the focal length of the concave lens has a focal length of 15 centimeter. So focal length is given as 15 centimeter. At what distance should the object from the lens be placed? So from the lens, at what distance the object is to be placed? That means they are asking you to find the object distance, that is u. Similarly, but what is given? So that is forms an image at 10 centimeter from the lens. So they have given the image distance, that is at 10 centimeter. To find u, you have to use the lens formula v and f. Make sure that you are using the sign convention correctly, because u here will also be negative and v here will also be negative, because both will be measured kept at the left hand side of the lens. Since it is a concave lens, both the image and the object will be obtained at the same left hand side of the lens. So both u and v and also f should be considered as negative. If you use the formula, you will find out what is u, and from that you can find out what is the value of m, which is equal to v by u. And the second example, this is the second example 10.4, which is given after the sign convention topic. A tall object is 2.0 centimeter tall object. Tall here represents the height of the object. So what is given here? Height of the object ho is equal to 2 centimeter. Is placed perpendicular to the principal axis of the convex lens of focal length 10 centimeter. Since it is a convex lens, I told you the focal length will be considered as positive. Then the distance of the object from the lens is 15 centimeter. Distance of the object from the lens is what? The object distance, that is u is equal to 15 centimeter. But here the object will be always be placed on the left hand side. So I am using a minus. So u is equal to minus 15 centimeter. The negative sign is because it is placed at the left hand side of the lens. With this, you have to find out v from the lens formula and the magnification of the image. So use the lens formula and find v, and then for the second magnification, equate hi by ho is equal to v by u. So hi is what? We don't know that. ho is what? It is given as 2 centimeter. U it is given, and v we would have found out from the step 1. So if you equate all these 4, you get the value of hi. So after finding hi, equate it as, you get how many, that is how many times the image is either enlarged or diminished. Once again, I repeat the most important point of magnification. Negative sign in magnification shows that the image is inverted and real, whereas a positive sign in magnification shows that the image is virtual and erect. The next topic is power of the lens. So, the ability of the lens to converge or diverge the light rays which is incident upon it depends upon the focal length. A lens will be having a focal length of its own which is provided by the manufacturer. Okay, so the ability of this lens, how much it converges or how much it diverges, depends upon the focal length. So, that degree of convergence or divergence is expressed as power of the lens. So, the proper definition is the power of the lens is defined as the reciprocal of its focal length. These are most important and most frequently asked points, and these points you are supposed to remember it while working out your problems also. So, all these 6 points are very important. So, SI unit of power is denoted by the letter capital D, and the SI unit of power is called as diopter. Okay, so 1 diopter is the power of the lens whose focal length is 1 meter. So, 1 D is equal to 1 per meter. If the focal length is given in meters, you are supposed to use the formula P is equal to 1 by F. In case if the focal length is given in centimeters, you are supposed to use the formula P is equal to 100 by F if focal length is given in centimeter. This is very important while working out, because most of the problems we would be using P is equal to 100 by F, since most of the focal lengths will be mentioned only as centimeters. And the next important one is power of the lens is directly proportional. That is, if the power of the lens is positive, then it is a convex lens. Power of the lens is negative, then it is a concave lens. So, power of the lens, if it is positive, then it is a convex lens. Power of the lens, if it is negative, then it is a concave lens. So, power and the positive and the negative sign, it is very important. We shall see one example here. So, a lens, it is given, we don't know what type of lens that is, has a power of plus 2.0 diopter. So, that means since the positive sign is given, we can directly say that it is a convex lens, and we are supposed to find the type of lens which we have found out from the sign and the focal length of the lens. So, power is equal to 1 by focal length. So, we can internally we can term that focal length is equal to 1 by power. So, we know that 1 by 2 here. Here the power is given plus 2. So, 1 by 2 I am substituting. So, I get 0.50 meter is the focal length of the given convex lens. The last topic is combination of lenses. So, we have seen about convex and concave, 2 types of lenses. It is not that they are used alone. Once it is combined together, it serves a higher purpose, like it increases the magnification and sharpness of the image. So, most of the times for practical applications, both the convex and the concave lenses are combined and used together. So, when such a combination of lenses are given, so how will you find out the power of the lens? So, power, it is actually is equal to sum of the individual powers. So, capital P is equal to power of the first lens, power of the second lens, power of the third lens. It can be any combination. It can be like convex, concave, or all convex. It can be of any combinations. So, therefore, from the power P is equal to, we can write internally as 1 by F1, that is a focal length of first lens, plus 1 by focal length of second lens, plus 1 by F3 focal length of third lens, and it goes on. So, such type of combination of lenses are used for practical purposes like in cameras, microscopes, telescopes, etc. Hope you have understood the topic. Thank you for listening.